I'm going to talk about question number 2 in your integration assessment, and I'm going to focus on the best use of GDC. So you can solve all this entire question, and get 8 marks without actually doing a single calculation by hand. All can be done with GDC. Let's look at the first question. On the grid below, sketch the graph of V, where V is given by this formula, by the formula here. So of course I'm going to get my GDC and put this as a function y1. So here is my function y1. But before I graph it, I would like to see on the screen exactly that part of the graph so that I don't struggle when moving from the screen of my GDC on this diagram. So I'm going to set my view window according to exactly the length of the axis that I see on this diagram. Here is my view window. And here is the X range and the Y range for my view window. Now I'm ready to press the draw button and to graph that function. This is my graph. This is exactly what I'm going to copy on the diagram. You need to make sure that the position of the important points on the graph are correct. An important point on the graph would be the maximum point, which is at the X value is between 0 and 1, the Y value is somewhere above Y equals 2. My graph passes through 0, 0, and I need to make sure I hold the shape, so the shape of the graph is similar to what I see there. Now look at the next question. The next question asks to find the distance traveled in the first 3 seconds. We know that the distance traveled is integral from 0 to 3, absolute value, v of t dt. So I'm not going to do this by hand. I'm just going to put it in my GDC. And I won't type again the value of the expression for v, because remember we type it there, so it's under y1. So if I'm going to recall it, going variables, and then y variable, and I'm going to choose y1 from that screen. So it will look like that, and the total distance traveled is 3.33, 3 significant figures. Let's look at the last question. The last question asks to find the velocity of the particle when the acceleration is 0. So if you want the acceleration to be 0, what the majority of you did, you wanted to find the acceleration, and very well you knew that the acceleration is a derivative with respect to time of v of t. So you have started to differentiate this function v algebraically. Many of you made a mistake when differentiating, because actually you should recognize that this is the product rule. You have a product of two functions, so you need to use a product rule to differentiate. But you don't need to, because your calculator can do this for you. Remember that your GDC can draw the derivative of a function. So your GDC can draw the derivative, can draw the acceleration, and also it can see where the acceleration is 0. Let's see how we do it. So under y2, I just have the derivative with respect to x of y1. Remember, y1 was the velocity, so the derivative of acceleration. Practically y2 is the acceleration function. And if I press a draw button, it will graph for me the acceleration. The red line represents the acceleration. Now you want to see where the acceleration is 0. This is the point where the acceleration is 0. So you need to look for x-intercept, which your GDC call it 0. Yeah? So you need to find this point, which is called the 0 of the function. To find the 0 of a function, you'd go calculate So you choose this option, calculate, and you get a menu where from you choose 0. So this is your 0, so your GDC found it, and its value it's for t equals 0.588, which you see here. So this t gives you an acceleration of 0. You need to find the velocity when the acceleration is 0. So the velocity is a blue graph, and this is a point that you need to find. The velocity of the acceleration is 0. Oh, see, the velocity seems to be at the maximum when acceleration is 0. That's not the aim of the question, but you can ask yourself this question. Is it the maximum point of the velocity when the acceleration is 0? So how am I going to find? Just replacing t equals 0.58 into the velocity function, but again, I don't need to do it by hand. My GDC will do it for me. Remember the table option. It gives you a table of values. So you can find the value of y1 when x is 0.588. And here it is. For this x that I typed, I find this velocity. And this acceleration, see, it's 3 times 10 to the power of negative 6. It's very, very close to 0. To 3 significant figures, it is 0. So my velocity is 2.16 to 3 significant figures. And the GDC solved all the problem for you. You didn't make a single algebra or arithmetic calculation.